All right, this is Algebra 2. This is lesson 66 on page 278. The first part of this lesson is signs of fractions. I have told you this before, however, it becomes extremely important now. In fact, it becomes so important that we also do this in pre-calculus today. So a fraction has three signs. The numerator has a positive. The fraction as a whole has a positive or negative. And the denominator has a positive or negative. All right. If I change any two of the signs, then I don't change the value of the fraction. Such as, if I have negative 3 over 4. I have a positive, I have a negative, I have a positive. I can change this sign and it'd be the same value. It's negative 3 over 4. Same value. I do not change it. Change the value of it. If I have 3 over 4 minus x, that whole binomial has a sign, the numerator has a sign, and the fraction has a sign. So I can change two signs without changing the value of it. I'm going to change the sign out here, and I'm going to change the sign in the denominator. So that it becomes 3 over, actually I'm going to change the numerator. I think I'm going to change the sign in the numerator. I'm going to make that a negative 3. I'm going to make that a negative 4 minus x. Right, I'm changing the sign, the entire value of that denominator. When I distribute that negative, it becomes negative 4 plus x. You agree so far? I can swap. The commutative property of addition says I can commute the x to the first place and the 4 to the second place, and it can be negative 3 over x minus 4. Right, all I did was, you see how I got from here to here? So that the value of this is the exact value as the original term. All I did was change two signs. I have to change two signs. I can't change one. Then I change the value. You with me? Why is this important? Because look at example 1. I can use this concept. It's as though I'm multiplying by two negatives, right? And two negatives make a positive. All right, look at example 1. It's 1 over x minus 3 minus 7a over negative x plus 3. Look at those denominators. Are they very, very similar? Can I make them similar? How? Yes.
You can use the commutative property of addition on one of the denominators.
Yes, Therese?
You can pull out the negatives from the, so you take...
I can change
the two signs.
two signs. What sign are you going to change? The numerator? Here or here? Numerator and denominator. That, okay? So it's 1 over x minus 3 minus, that one that we're not changing, right? We're going to change the numerator, and we're going to change the denominator. Following me so far? As long as I change two signs, I don't change the value. So I end up 1 over x minus 3 minus negative 7a over x minus 3. Now I have a common denominator. When I change two of the signs in the second term, I end up with a common denominator. Now what can happen? The sign moves to the numerator, and I can write everything over the common denominator. When I move that sign up, it's 1 minus negative 7a, which is 1 plus 7a over x minus 3. So all I had to do was change two of the signs in that second term. You may have to change two of the signs in the first term. Yes?
So you can change the middle sign too?
Yes, yes. So I could have said, I'm going to change this sign, I'm going to change that sign.
Plus 7a over
Correct, because don't I end up with the same thing? Right? Remember in algebra, the sign that we used to read as subtraction actually attaches to that term that follows it. Okay? Does that make sense? All right, let's look at the second example. All right, 4x plus 5 over x minus 3 plus 2x minus 3 over 3 minus x. You look, the denominators. If I just change the sign of one of the denominators, then I have a common denominator. It doesn't matter which one, but my preference is it's x minus 3, not 3 minus x. So what signs do we want to change? We can change the numerator. We have to change two of them. The numerator, I can change this sign, and I'm absolutely going to change the denominator. So which one are we going to change? Which one do you want to change, Jesse? Numerator or this sign? Did I point to the right one? Yes. It doesn't matter. Which one?
The
Numerator. All right, so I end up with 4x plus 5 over x minus 3. I'm not changing that sign. I'm going to change the sign in the numerator. I'm going to change the sign in the denominator. You see how I'm doing that? All right, so I end up with 4x plus 5 over x minus 3 plus negative 2x plus 3. Notice every sign for every term changes. I'm going to write it as x minus 3. Now I have a common denominator. I can move the sign to the numerator and write the entire numerator over that one common denominator. Because it's plus, none of the signs of any of the terms changes. Now I can combine my like terms. I end up with 2x plus 8 over x minus 3. This is the final answer. All right, so that's simply multiplying two terms in a fraction by a negative so that I end up with a common denominator. Okay? The second part of this lesson is 30, 60, 90 triangles. And it is a Pythagorean triplet. We talked about this last year. We've already talked a little bit about it this year. But if I have a 30, 60, 90, what's that Pythagorean triplet, Will?
1 squared root of 52.
Right. Opposite 30 is the 1. Opposite 60 is square root of 3. Opposite the right angle is 2. Why is this important? Because I can look at any 30, 60, 90 triangle and solve for any of the other ones. I am not using my calculator or, which you would use your calculator for, I'm not using Pythagorean theorem if I have a 30, 60, 90, and I'm not using sine, cosine, or tangent in my calculator. I'm using the knowledge of this triplet to solve for every side. So if the hypotenuse is 10, where do we go first? To what? Opposite 30. Opposite 30, how is it related to the hypotenuse? It's half. 2 to 1, we take half of it. So this is 5. Always go to opposite 30 if you can. Well, always, period. You always can. Always go to opposite the 30. And then to go from the 30 to opposite the 60, what do I do? What do I do to 1 to get to square root of 3? Multiply by square root of 3. It's 5 square root of 3. All right, what if I have opposite 30? Where do I go next? Michael, where would you?
Hypotenuse.
The hypotenuse is going to be what?
It's 14.
It's twice. The hypotenuse is twice the side opposite the 30. And Corinne, what's the other side? It'll be opposite the 60.
And it's, would it be 7 square root of 3?
Yes, you're just multiplying that term by square root of 3. Okay, what if I had something like that? What is the hypotenuse, Ashley?
Wouldn't you multiply it by 2?
Multiply by 2, so it's
Just 2.
Nope, 2 squared.
2 square root of 3. Mackenzie, what would this side be?
No, square root of 6.
I meant 2.
It's 2 squared root of 2.
2 square root of 2. I have 3 in my brain. I'm saying to get from here to here, you multiply whatever you have by 2. So 2 times square root of 2 is,
It's not square root of 2 times square root of 2. That gives you 2.
got it? Got it. So how do I get from here to here? I multiply by
Square root of 3.
square root of 3, which is
Square root of 6.
square root of 6, okay? I don't think there's any crazy one like that, but it did occur to me to maybe do one like that. Okay, now what if I begin here? Michael.
Divide by square root of 3.
So it's 6 over square root of 3, but we're in algebra. So what do we do?
Simplify the radical.
So how do we do that?
Multiply both the numerator and the denominator by square root of 3.
So we end up with 6 square root of 3 over 3, which is 2 square root of 3. Okay, so let's see a pattern. How do I get from 6 to 2 square root of 3? Do I multiply by square root of 3 over 3? Is that the same answer? Yes, it is. So to get from 60 to 30, what do I do? You can know that you're dividing by square root of 3, right? Dividing by square root of 3, so 1 over square root of 3 is the same thing as the square root of 3 over 3. Do that in your calculation, see if that's really equivalent. What is this in decimal form? And then somebody give me this in decimal form. What is this?
0.577.
Okay, and what is this?
0.5.
It better be the same. Why? How do I get from here to here? I just multiply by square root of 3 over square root of 3. Okay? So, to get from opposite 60 to opposite the 30 degrees, you just multiply by square root of 3 over 3. Or you can remember, divide by square root of 3. Yes?
And this only applies to triangles with the 30, 60, 90.
Only. That is correct. Okay, so now I'm going to tie this into the ACT. Because that's important. How at every 30, 60, every equilateral triangle, when I draw the altitude, so if I begin with an equilateral triangle and I draw the altitude, it's a 30, 60, 90 triangle. Okay? So what do they do oftentimes? Give you an equilateral triangle. The length of one side is 6. What's the area of that triangle? Okay, well you have to know, when I draw the altitude, it becomes a 30, 60, 90. This base is split in half, and then we have a 30, 60, 90. I can now calculate the altitude. What's the altitude? 3 square root of 3. Can I now calculate the area? Yes, 1/2. 6 times 3 square root of 3, right? Because it's base times height. Got it? Okay. Now, I want to look at the unit circle, because the unit circle, we will spend several months on this next year. And you'll have to have this memorized. But remember, I already told you something about the unit circle. What is that sentence that I said that can tell you? Do you remember the sentence I gave you?
All students take calculus.
All students take calculus. All students take calculus. Did you say that grimacing? Thank you. Thank you. What does this give me? What information does this give me? Yes, Hannah.
What's positive in each of the quadrants?
Which trig ratios are positive in which quadrant? In the first quadrant, all of them are positive. Sine, cosine, tangent. There are 3 more on your unit circle. Secant, cosecant, and cotangent. We'll do those next year. Okay? In the second quadrant, what's the only one that's positive? Sine. Third quadrant. Fourth quadrant. Okay? I've also taught you when we are solving for that x value or that r value, which trig ratio do we use? One knows. X goes with R goes with cosine. Remember, R cosine, you sine. Remember that crazy? R cosine, you sine. I don't know. Remember it. R cosine, you sine. So if I'm thinking about x and y coordinates, the x goes with the cosine, the y goes with the sine. Got it? All right, if I just draw a 30-degree angle, what's the Pythagorean triplet? It's 1, square root of 3, 2. Okay, so we're going to also tie this into vectors. If this were a vector, what would be the cosine right here? What would be the cosine of that angle? What over what?
Over 30. Would it be 1 over square root of 30?
Cosine equals what over what? What's the adjacent? Adjacent over hypotenuse. You see that? So the cosine here would be square root of 3 over 2. What would the sine be? 1 over 2. Look on your unit circle. Look at that 30-degree angle. You see in the parentheses? That first one is the cosine. Square root of 3 over 2. You see the second one is the sine. You see that? All right. Now, do y'all remember the 45, 45, 90 triangle? What's the Pythagorean triplet for 45, 45, 90?
1, 1 square root of 2.
1, 1 square root of 2. Okay, I'm going to draw it here on the board. 1, 1 square root of 2. All right, so here is my 45. This is the 45. I can write 45 over here because it's 45, 45, 90. And it would be 1, 1 square root of 2. So looking at the red triangle, with this being the 45-degree angle, what is the cosine? If this is the 45-degree angle, look over here. It's adjacent over hypotenuse. What's the adjacent? 1 over. So it'd be 1 over square root of 2. But do we leave that radical in the denominator? No. We multiply by square root of 2 over square root of 2. And what do we end up with? All right. So the cosine would be square root of 2 over 2. What would the sine be?
Square root of 2 over 2.
Because it's the same. So when I have a 45, 45, 90, what is true about the sine and the cosine? The exact same ratio, right? Their ratios are exactly the same. All right, now let's look at what if instead this angle was 60 degrees. All right, so I'm going to draw the triangle over here. Now we have the 60 degrees. Here is the 30 degrees, but we're looking at the 60 degrees. So this would be 1 square root of 3 over 2. You agree with this? So if I'm looking at the 60 degree angle, what is the cosine? 1/2. You agree? 1/2. All right. So the cosine is 1/2. What is the sine? Opposite. So square root of 3 over 2. Look what happens from the 30 degree to the 60 degree. What happens? They swap. Do you see that? All right. Look what happens to the cosine. Let's just isolate on the cosine. Cosine numbers. Okay. We should go here. Right at here, if I had 0, here's the unit circle. If this were 1 and this were 0 and the point is there, what is the cosine? What value does the cosine go with, x or y? Okay. What would be this coordinate point on the Cartesian coordinate system? It would be 1, 0. You go x1 up 0. Guess what? Cosine, sine. 1, 0. Got it? Okay. All right. So now we can focus on the cosine. Look at the cosine. It goes from 1 square root of 3 square root of 2 to 1. The denominators for all of these are 2. The cosine actually counts down from 1 square root of 3 square root of 2 to 1. 1 square root of 3 square root of 2 to 1. Knowing that the last 3 the denominators are. And we go from a 30 to a 45 to a 90. So the cosine counts up or down? Down. 1 square root of 3 square root of 2 to 1. Got it? Okay. What does the sine do? Counts up. 0, 1, 2, 3. You see that? So it's 0, 1/2, square root of 2 over 2, square root of 3 over 2. Look what happens in every quadrant from the x-axis. All right. So let's go. Well, I have it upside down. Let's go to the 180 degrees. And we're going to go up. All right. What happens? How does this second quadrant compare to this first quadrant in terms of the ratios?
It's mirrored. I mean,
Is it? Okay. So at 180 degrees, what's the cosine? -1. What is the cosine at the 150?
Negative square root of 3 over 2.
So how does it differ from the 30 degrees?
The sine is different.
The cosine is negative.
It's the same number, but the cosine's negative. Why? Because only in the second quadrant the sine is positive. The cosine's going to be negative. The ratio doesn't change. What happens at 135 degrees? The cosine is same value but negative. What happens at 120 degrees? Same value but negative. What happens to the sine? Is there any difference in the sine values? Between the first, none, 0. You know why? The sine is positive. Okay, what happens in the third quadrant? The tangent is positive. So what are the sine and the cosine going to be? Negative. Okay, is that true? All right, so let's go up. Remember when we do vectors, we always go from the x-axis, right? So you're always going from the x-axis. So we're going up 30 and down 30. Okay, how do those ratios compare? Are they the same numbers, just the negatives?
Yes.
You agree? All right, now go up to 45 and down to 255 or 225. It's hard to read from backwards. Same, but both negative, same values?
Yes.
Are you seeing this? All right, go up to 60 and down to 240. Same values, but both are negative. Okay, let's go to quadrant 1 and 4. What's positive in quadrant 4? Cosine. So what are you expecting? Same cosine ratios, but negatives. All right, so go up 30 down to 330. You see that? Cosine's positive, sine is negative. Go up to 45 down to 315. Up to 60 down to 300. Okay, so every quadrant repeats the same ratios. So what tells me what quadrant I'm in is the degrees. I'm at 0, I'm at 90, or 180, 270, back around to 360. But I'm only going to memorize this first quadrant. Because if I can figure out what the distance is from the x-axis in the second and the third, or the x-axis down negative in the fourth, and I have that first quadrant memorized, then I've got it. All right, cosine counts up or down? Down. Sine counts? Okay, let me tell you why. Look what the graphs look like. The cosine starts at 1. I should write degrees. This is degrees. All right, it starts out at 1. What is the cosine at 90 degrees? Look on your unit circle. What's the cosine at 90 degrees?
0.
What's the cosine at 180? Negative 1, 270,
0.
and 360.
1.
Look what it does. That's the curve of the cosine. It counts down, just like the ratios. What does the sine curve do? It starts out at, goes back to,
0.
down to, back to. Here's the sine curve. All right, so what is the unit circle made up of? 30, 60, 90, and 45, 45, 90 degree triangles. If you know those ratios, you can figure out what the unit circle is.